As we come to the end of Lesson 1 in Section 3, let's examine a couple of typical probability problems involving single events. The probability is high that you have encountered problems of this nature before. A spinner is divided into 5 equal sections, or 5 equal sectors. They have been labeled as A, B, C, D, E. We could also identify them by color: brown, blue, orange, black, and green. We're going to determine the following probabilities as a fraction, a ratio, a decimal, and a percent. Our first probability. What is the probability of spinning orange? We have one sector that's colored orange out of 5. So as a fraction in simplest form, the probability of spinning orange is 1/5. We can easily convert that to a ratio, 1 to 5. To get our decimal and percent, it's going to take a little bit more work, but nothing too difficult. We will write this fraction out of 100. An equivalent fraction will be 20 out of 100, which in turn gives us 20 hundredths, or 2/10, and our percentage, 20%. The probability of spinning a C. Once again, we have one sector labeled C, 1 out of the 5. All of our other forms then will be the same as what they were in the previous example. How about the probability of spinning a vowel? Our vowels include A, E, I, O, U. On our spinner, we have an A and we have an E. 2 sectors with a vowel, 2 out of the 5. That is a fraction in simplest form, so we get the ratio, 2 to 5. Let's create an equivalent fraction to help us figure out the decimal and the percentage. 2 times 20 gives us 40 hundredths, so our decimal, 0 and 40 hundredths, or 0.4, and our percentage, 40%. The probability of spinning a color beginning with B. On our spinner, we have a brown sector, we have a blue sector, we have a black sector. Orange does not begin with B. Green does not begin with B. We have 3 out of the 5 sectors having a color beginning with B. That too is simplest form. The ratio then, 3 to 5. Let's create an equivalent fraction out of 100, so we get 60 hundredths, or 6/10, and our percentage would be 60%. And our final probability here. What is the probability of spinning A, B, C, D, or E? That's all 5 sectors. So if we spin our spinner, we got to get one of them. Therefore, the probability would be 5 out of 5, or you could say 1 out of 1, or probably even better, just 1. As a ratio, I would express it as 1 to 1. In terms of a decimal here, we would just write the whole number, 1, and our percentage, of course, there's a 100% chance that we're going to spin one of those 5 letters. And our second example, the names of 10 students are in a hat. You randomly pick one name. Determine the probabilities as a fraction, ratio, decimal, and percent. What is the probability of Hugo getting picked? That name appears in the hat once. 1 out of 10. That would be our fraction, which is simplest form. The ratio, 1 to 10. As a decimal, this one is probably even easier. 1/10 would be 0.1. If we write this fraction out of 100, the equivalent fraction would be 10 out of 100, which gives us 10%. What is the probability of Remy not being picked? Well, if Remy is not picked, that leaves 9 other names in the hat to pick from. Therefore, we have the fraction 9/10, which is simplest form. Ratio, 9 to 10. Our decimal, 9/10. And to convert that to a percent, we create our equivalent fraction, multiply numerator and denominator by 10, and we get 90%. How about this one? What's the probability that we will choose a name with 3 or more vowels? Our vowels again, A, E, I, O, U. If we look at our names that are in the hat, Bavika, that has an A, an I, and another A. That works. Do we have another one? Yes, Kira. Kira has 3 vowels, an I, an E, and an A. Those, however, are the only 2 names containing 3 or more vowels. Our probability then would be 2/10. Now, 2/10 is not simplest form. We do need to reduce. We get 1/5 by dividing numerator and denominator by 2, because the GCF for 2 and 10 is 2. We then get our ratio, 1:5. Our decimal, well, I can look at my fraction of 2/10. That gives me 0.2. And the percentage, 10 times 10, 2 times 10, 20, which of course gives us 20%. And our final probability. What is the probability of a 4-letter name being picked? How many of these names that are in the hat have 4 letters? We have Hugo, we have Lori, we have Remy. 3 out of the 10 names have 4 letters in them. That gives us a ratio of 3:10. Our decimal, 3/10. And last but not least, our percentage we can figure out, and that will be 30%. Please now proceed to the activities for lesson number 1.